Bismillahirrahmanirrahim. Assalamu alaikum, dear friends. In today's lecture, we are going to talk about the nuclear stability. Basically, it's observed that there are many isotopes that are quite stable, and some of the isotopes are known as the unstable isotopes. So, basically, we are going to talk about the concept of stability, and we are going to talk about which isotope or which nuclei would be called as the stable and which is called as the unstable, and then we will talk about the criteria upon which we can classify a nuclide or the isotope of an element as the stable or the unstable. So basically, nuclei are divided into stable and unstable nuclei. So if we talk about what is a stable nuclei, so a stable nuclei remain unchanged over a long period of time up to 10 to the power 21 years. So basically a stable nuclei is that which remains stable or which remains unchanged over a long period of time, and it undergoes no change in its nucleus or in the composition of its nucleus over the long period of time. And what is regarded as a long period of time, it's basically the 10 to the power 21 years. As you people know that in the nuclear chemistry, a period of time is taken as very long. So if an element or if the nuclei of an element remains stable for 10 to the power 21 years, that would be known as the stable nuclei. So basically 274 naturally occurring nuclei are known as the stable nuclei. So basically you can look here that very small number of nuclei are considered as the stable because the period of time that is taken as the criteria for the stability is very long. And an example of the nuclei is given here. It's the tellurium 52130. So this isotope of the tellurium is considered as a stable isotope because it fulfills the criteria of the 10 to the power 21 years. The other type of the nuclei are the unstable nuclei, which undergo spontaneous changes in the composition of their nuclei. They may emit protons, they may emit neutrons, they may emit radiations in order to reorganize or rearrange their nucleons and to get stability. And in course of gaining the stability, they undergo changes in their composition, and about 2000 nuclei, both naturally occurring and man-made, are considered as the unstable nuclei. So basically we are going to talk about what are the criteria, what are different rules that decide whether a nuclei would be called as the stable or it would be known as the unstable. So first rule is the even odd rule. Basically this rule is concerned with the number of protons and neutrons, or you can say the number of nucleons. So nuclei with even protons and neutrons are considered as the stable. So all those nuclei which have even number of protons and even number of neutrons are considered as the stable, whereas those having the odd number of protons and neutrons are considered as the unstable. And this statement or this rule is based upon the observations that are made while studying the very large number of the isotopes. A table here is presented which shows the stability or the relative abundance of the nuclides with respect to their number of protons and the neutrons. So this table shows that number of protons, number of neutrons, the total number of protons and neutrons, or you can say that it's the atomic mass or atomic weight of the nuclei, the number of stable nuclei, and you can say that this column is dealing with the natural abundance of the stable nuclei, and this is related with the examples. So for even protons, even neutrons and nuclei, and when both the protons and neutrons would be even, the atomic mass would also be even. So 165 nuclei are found in this category. So that is the highest number of nuclei contains the even number of protons, even number of neutrons, and the even atomic mass. So the example of this particular kind is the helium-24. Many other examples are also present, but this is an example of the typical stable nuclei having both even protons and even neutrons. The next one is the category of nuclei having even number of protons, odd number of neutrons, and odd atomic mass. In this category, there are 55 stable nuclei found in nature. And the example of such a nuclei is oxygen 817. That's having the even number of protons and the odd number of neutrons, and the atomic weight of such nuclei is also odd. The third category is the odd number of protons, even number of neutrons, and odd atomic mass. And in this category, there are 50 stable nuclei found in nature. Example of such category is the lithium 37. And the last one is the category which contains odd number of protons, odd number of neutrons. This is even. When both the number of protons and neutrons would be odd, the atomic mass would be even. It contains total 5 nuclei, 5 stable nuclei in the nature, and the example of such nuclei is hydrogen 21. It's the deuterium. So you can look here from this table that the most abundant are the even combinations with 165 stable nuclei, and the least common is the odd combination with 5 stable nuclei in the nature, and those having even odd combinations are found in between. So this table also shows that this rule is correct. Nuclei having even number of protons and neutrons are most stable. It's also supported from the nature that in nature or in the earth crust, 85% of the nuclei that are found in the earth crust are belonging to this category, even category, even proton, even neutron, and the example is the oxygen 816. This isotope is found in the 48% in the earth crust. So its natural abundance is highest of all the elements found in the nature. The next rule that decides the stability of nuclei is the magic numbers. So nuclei are stable if the number of nucleons is equal to the magic numbers. Basically, nucleons is a term that is used combiningly for the protons and neutrons. So this rule says that if the number of protons and neutrons is equal to the magic numbers, they would be stable. So what are magic numbers? 2, 8, 20, 28, 50, 82 and 126. So these are the magic numbers. If the number of nucleons or the number of protons and neutrons is equal to these numbers, those nuclei would be stable, and those having number of nucleons other than these numbers would be unstable. Example is the oxygen 816. It's having 8 protons, that comes in the category of the magic number, and it's having the 8 neutrons, that also comes under the category of the magic numbers. So if the number of nucleons is equal to magic numbers, the nuclei are stable. But helium-24, it's an exception. It's not having magic numbers, but still it's a stable nuclei. So you must keep in mind that helium-24 is an exception to the magic number rule. The next rule is the N to P ratio, neutron to proton ratio. This rule says that nuclei are stable if N to P ratio is equal to 1 or greater than 1. So earlier elements in the periodic table, the N to P ratio is equal to 1. But as we move further in the periodic table, the number of neutrons becomes greater than that of the protons. So in heavier elements, N to P ratio is greater than 1. So all those elements or all those nuclei which are having the N to P ratio equal or greater than 1 are considered as the stable. So a plot is made on the basis of this rule, and that is known as the surge chart. So it's a plot that shows the number of protons and neutrons in various nuclei. And here you can look that this line, straight line, is showing the N to P ratio equal to 1. So this is showing that all those elements that would lie on this straight line would be stable. But it's actually observed that very little number of nuclei, or you can say the elements, follow this line. Up to this point, the N to P ratio is 1, but this is for lighter elements. As we move further in the periodic table, above the atomic number 20, the number of neutrons is not equal to number of protons. So this is the area that contains the stable nuclei, and the nucleons that are found in this area have their N to P ratio 1:2, and this is basically known as the stability belt. So what is stability belt? It's a region containing highly stable nuclei. Outside it, unstable nuclei are found. So all those elements are the nuclei that fall on this side of the stability belt, on this side of the stability belt, or below this line, are considered as the unstable. In this region, the proton to neutron ratio is 1:4. That's also unstable. In this region, or in the stability belt, the ratio is 1:2, and that's stable. So below this stability belt, nuclei are also unstable. So all those elements are the nucleons that are found within the stability belt are having special stability. So this was all about the nuclear stability. If you have any question related to this video, you can post your question in the comment section. We will meet in the next video. Until then, Allah Hafiz.